This is Jacob's Algebra, Chapter 14, Lesson 4, Part 2. This is my, actually it's a fairly decent attempt at the drawing that is in the textbook for problem number 8. The information for number 8 says the diameter of each circle in this figure is equal to half the side of the square. So what that means is when you're looking at the diameter for this circle, you can see the diameter is the distance from one side of the circle to the other side of the circle going through the center. And when you have two circles together, that the two diameters is going to take you all the way across one side. So we know that the length of one side of this square is twice the diameter of a circle. Or you can say that it's 4 times the radius of a circle, because we know that each circle has a radius of r. They all have the same diameter. That means they all have the same radius. The radius is half of the diameter. So the diameter is equal to double the radius. Okay, so part A asks for you to find the area of the square if the radius of each circle is 10. So for part A, we want to find the area of the square. And we know that r is equal to 10. Well, we know that this side is 4r. The other side, it's a square, has to be 4r also. And remember, when you are taking when you are getting the area of a square, you multiply the lengths of the sides together. So the area of the square would be 4r times 4r, which is 16r squared. We also know that the radius is 10, so we can plug in 10 in the place of r and say 16 times 10 squared. 10 squared is 100, so that means this has a radius of 1600. Then it says find the area of the square if the radius of each circle is x. That's part B. So the area of the square is still going to be 16r squared, but this time instead of r, we're going to replace our r with x. And so it is 16x squared. Okay, now part C is a little different. Part C wants us to find the area of all 4 of the circles. So the 4 circles together. Well, first let's find the area of one circle. The area of one circle is going to be pi r squared. That means the area of 4 circles is going to be 4 times as much. So it's 4 pi r squared, because we have 4 of them, so it's pi r squared times 4. All the circles are the same size, so we can just multiply by 4. If they were different sizes, we'd have to figure out pi r squared for each of the circles, and it would be different for each of the circles, and then add them all together. But these all have the same radius. Okay, and then it tells us that r is 10. So this is going to be 4 times pi times 10 squared, and 10 squared is 100, so that is 400 pi. And it says to give the area in terms of pi, so we're going to leave pi in our answer. We're not going to try and replace it with anything. Okay, part D says find the green area if the radius of each circle is x. Well, we already said it was 4 pi r squared. 4 pi x squared is going to be our answer, and we can't actually do anything more with that. And that's the area of all 4 circles, not the area of just one. The area of just one of the circles would be pi x squared, but since there are 4 circles the same size, it's 4 pi x squared. Okay, that was problem number 8, which is just like, well, very similar to problem number 15 that you have in your homework. In problem number 15, you have just one circle inside of a square. Okay, let's look now at problem number 9. Okay, problem number 9 shows you 2 circles. So we have an outer circle and an inner circle, and the area in between the 2 circles is shaded. Okay, that's my lousy shading, but it's the best I can do. Okay, so it says the diameter of the larger circle is twice the diameter of the smaller circle. Well, if you remember, diameter is the distance all the way across. So I'm going to draw a line that goes all the way across through the middle. And I'm going to call the bigger circle 2 and the smaller circle 1. So I'm going to write, well, if I can get it back into pen mode, the smaller circle is 1, the bigger circle is 2. So I'm going to say the diameter of 2 is twice the diameter of 1 because that's what they just told us. The diameter of the larger circle is twice the diameter of the smaller circle. And they want you to find the area of this shaded region if the radius of the smaller circle is 3. So if R1 is equal to 3, that's the radius of the smaller circle. R1 would be this distance from the center to the edge. That's R1. So R1 is 3. If R1 is 3, what is the area of the shaded region? Which is supposed to be this entire area between the two circles, but I can't do that on the computer. Okay. So in order to do this, what we're going to need to do is find the area of the larger circle and subtract the area of the smaller circle. The area of the larger circle would be pi r2 squared. The area of the smaller circle would be pi r1 squared. And to get the area of the shaded region, we have to subtract these two. Okay. Now we know that the diameter of the larger circle is twice the diameter of the smaller circle. That means because radius is half of the diameter, that the radius of the larger circle is also twice the radius of the smaller circle. So we know that our R1 is 3. We know that our R2 is the double of that. So our R2 must be 6. So we can place these numbers in here. This is for part A. And for part A, we can say pi times 6 squared minus pi times 3 squared. That's 36 pi minus 9 pi, which is 27 pi. And it says to find the area in terms of pi. That means we leave pi in our answer. So 27 pi is the shaded area. Then it says, what if the radius of the smaller circle is x? Okay, so we've got something a little different this time for part B. We're still going to use pi r2 squared minus pi r1 squared. But this time, r1 is equal to x, and r2 is equal to 2x. So I'm going to replace my r2 and my r1 with 2x and with x. So we have pi times 2x squared minus pi times x squared. Remember, this 2 gets squared also because 2 is part of the radius. So this is 4x squared pi. Sorry, that's supposed to be a pi. Minus pi x squared, which I'm going to rewrite this because that looks horrible. That's 4 pi x squared. And that's going to be 3 pi x squared because we had 4 of the pi x squared and we took away 1 of the pi x squared. So that means we have 3 pi x squared. So that's going to be the area of the shaded region when the radius of the smaller circle is x. Okay, question C is a little different. Question C wants to know what fraction of the area of the larger circle is shaded. Okay, because part of the area of the larger circle is shaded, but this interior area is not shaded. So what fraction of the larger circle is shaded? Well, we know that the shaded region is 3 pi x squared. 3 pi x squared. The area of just the larger circle, the entire larger circle, we know that is, sorry, where do we find that? We know that is 4 pi x squared. 4 pi x squared. So if we divide the part that's shaded by the area of the entire circle, then what we get is 3/4. That is the fraction because our pi's cancel and our x squareds cancel. So 3/4 is all that we get. We can also do this with the numerical values that we already determined. In part A, if we use 36 pi as our entire circle area, and then 27 pi as our fractional area, pi divided by pi cancels. 27 and 36 are both multiples of 9. 27 divided by 9 is 3. 36 divided by 9 is 4. We still end up with 3/4. Okay, that was number 9, which is similar to number 16. Okay, the next one we're going to work on is problem number 10, which is the last problem in the section. It's very similar to problem number 17. In problem number 10, we are told to let pi equal 3.14, and we're told to round our answer to the nearest integer. Okay, so we are going to be rounding our answer to the nearest integer at the end. Don't round to the nearest integer until you're at the very end of the problem. And we're going to replace pi with 3.14. Okay, so part A says, find the approximate circumference of a hula hoop if its radius is 18 inches. So the radius is 18 inches, and we need to find the circumference. Well, remember that circumference is 2 pi r. So I'm going to say 2 times 3.14, because it said to use 3.14 for pi, times our radius, which is 18. And 2 times 3.14 times 18, that's going to give us 113.04. But it says to give our answer to the nearest integer. The nearest integer to this is 113, and we're going to be in inches. Because our radius was in inches, our circumference must also be in inches. Okay, part B. It says find the approximate radius of a person's neck. So we're trying to find the radius if the circumference is 14 inches. So C is 14 inches. Well, remember circumference is 2 pi r. So 14 is equal to 2 times 3.14 times r. So to solve this problem, we need to get r by itself. So 2 times 3.14, that's 6.28. 14 equals 6.28 r. So now we need to divide both sides by 6.28 to get r by itself. And we'll see that r is equal to, where did I calculate that? 2.23. And we need to round that to the nearest integer. So we're going to say that r is 2 inches. It has to be inches because inches are what we had in our circumference. Okay, let's do 2 more. So we're continuing on with number 10. Remember, for pi, we are going to use 3.14, and we're going to round to the nearest integer. So part C and D use area. Part C wants you to find the area of a sand dollar, circular sand dollar, that has a radius of 4.1 centimeters. So R is 4.1 centimeters, and we need to find the area. Remember, area is pi r squared, and that's what we're trying to find. Pi is 3.14. Our r is 4.1, and we're going to square that. So when we punch all of that into a calculator, what we get is 52.7834. But it says round to the nearest integer, so we're not done yet. This is our integer, so our area is going to be 53 centimeters squared. Because our radius was in centimeters and we squared it, that means we square our units too. So we had centimeters. When we squared our radius, we got centimeters squared. Okay, just one more part here we're going to do. Part D says find the approximate diameter. Watch out, because we're being asked for diameter, not radius. Find the approximate diameter of a circular radar screen if its area is 1,260 centimeters squared. So the area is 1,260 square centimeters, which is centimeters squared. Okay, so remember area, which is 1260, is going to be pi times r squared. And we know that pi is 3.14, so 1260 equals 3.14 r squared. So the first thing we need to do is get our r by itself. So we're going to divide both sides by 3.14. And we will get that r squared is equal to, excuse me, 401.274. Now, to find out what r is, we need to take the square root of both sides. So that will tell us that our r is 20.03. But they didn't ask for the radius. The question asked for the diameter. And remember, the diameter is the double of the radius. So diameter is equal to 40.06. And we round that to the nearest integer, which is 40. And our answer is going to be in centimeters. Because we had centimeters squared, When we squared our radius, we had centimeters squared. When we took the square root, we got the just plain centimeters.